Today on Capecci's Corner, we are going to talk about properties of real numbers. Now, you've looked at real numbers in Algebra 1, but sometimes I feel the vocabulary words can be a little confusing when we're looking at everything. So we have real numbers and we actually have imaginary numbers, which we'll get to later in the Algebra 2 course. So right now, we are just concentrating on real numbers. So when you look at this graph, these graphics here will help you. So real numbers is going to be everything we're talking about. And we're talking about first about natural numbers right here. Now, natural numbers, I like to say, are counting numbers. So if you ask someone to count, they're naturally going to start at 1. So it's 1, 2, 3, and the numbers keep going. They are counting numbers. So the lowest value there is 1. Now, when you look at whole numbers also includes natural numbers. So not only are we including those numbers, but we are also including 0. That's the other part of it that's added. We are not using negative numbers, and we're not using fractions or decimals. When we're talking about integers, we are looking at any whole number. So again, 0 and any positive number. Now, also on top of it, we're talking now also including negative numbers. Again, no fractions and no decimals. Now, the other part of this, we are going to compare rational numbers with irrational numbers. And I think these are the ones that get a little bit confusing to students. So rational numbers are any numbers that can be written as a fraction. So if you look at these in your graphic up here, that could be anything like 3/4. It can and includes integers. For instance, 7 is an integer, but 7/1 is a fraction. We can make that a fraction, so that's included. Okay. Now, when we are looking at irrational numbers, what's the difference there? They're numbers that cannot be written as a fraction. The decimal form neither terminates nor repeats. So, for instance, the square root of 10, we cannot make that a fraction. It's just a decimal that doesn't kind of go in any random, kind of just keeps continuing. And again, like it says, they're not terminating, meaning they're not ending, and they're not repeating. Okay, pi is another one that we see a lot. So they are irrational numbers. Now, all of these are considered real numbers. So if you get stuck, I would just say go back to this graphic and see if that can help you. Now, the second part of this lesson, again, is properties of real numbers. And I know that you've had this not only in Algebra 1, but probably a pre-algebra course. So we're just going to review these so you can use these throughout the Algebra 2 course. So our first property we have is commutative. Okay, so commutative we can use with both addition and multiplication. And what that looks like is it doesn't matter what order we put it in. So for commutative, for instance, a plus b equals b plus a, we can say 6 plus 3 is also equal to 3 plus 6. That's a true statement. Same things happens when we multiply. If we multiply 7 times 2, we can reverse that and get 2 times 7, and we also get a true statement there. Now, the associative property, that's the one that we get when we're using parentheses. I like to say, who do you associate with? Who do you hang out with? Who are you grouped with? That's the grouping symbols. So if I'm going to add 4 plus 1 plus 2, that's the same as saying 4 plus 1 plus 2 in parentheses. So in addition, it does not matter how I group it. The answer will be the same. For instance, on the left-hand side, 4 plus 1 is 5, plus 2 gives me 7. On the right-hand side, if I do my grouping symbols first there, I get 1 plus 2 is 3, plus 4, and I still get 7. Same thing is true with multiplication when we're talking about associative property. So if I have something like 5 times 1 times 3, if I change what is grouped, what is in parentheses, I'm still going to get the same answer. So whether I have 5 times 1 on the left-hand side, which is 5 times 3 gives me 15, or on the right-hand side, if I do 3 times 1 first, which is 3, times 5 gives me 15. Now, when I go to the identity property, it's a plus 0 is equal to a. So 7 plus 0 gives us 7. Doesn't matter where the 0 is or our variable, we're still going to get 7. That's considered the identity property of addition. So kind of whatever you put in, you put out. Same thing with multiplication. We get that when we multiply things by 1. So 16 times 1 gives me 16. 1 times 16 gives me 16. Again, you're multiplying it by 1. You're going to get the same variable or the same value you started with. Now, when we're looking at our inverse property, inverse means the opposite. So if I have A and I add negative A, I'm going to get 0. So 3 minus 3 or plus negative 3 gives me 0. Same thing, it doesn't matter if I have my negative symbol first. Negative 4 plus 4 also equals 0. Now, to use the inverse property of multiplication, we're going to multiply by the reciprocal. So 5 times the reciprocal of 5 is 1/5. That is going to give me 1. Same thing if I have my fraction first. 1/7 times 7 gives me 1. So that's the multiplication portion of our inverse property. The last property we're going to do today is a distributive property, which you've done in Algebra 1 and probably in a pre-algebra, so this should be pretty familiar to you. So when I have distributive, if I have a monomial up front and a binomial, I'm going to distribute A times B plus A times C. Now, this binomial could also be a trinomial or another polynomial, but that's the idea. So 2 times x gives me 2x, and then 2 times 4 gives me plus 8. Now, that's what we're comfortable with, the monomial up front. If I have the binomial up front, it's still the same idea. I'm going to distribute that A, but we just are more comfortable with that first way. Still the same thing. 2 times x gives me 2x, and 2 times 4 gives me plus 8.